The James Webb Space Telescope, JWST, is catching light that has been going for north of 13 billion years. The universe has been extending this light so that for the most far-off cosmic systems, we are thinking back nearly to the Big Bang. The endlessness of the universe may appear to be unlimited, yet everything started from what we allude to as the peculiarity. This is our current comprehension of the Big Bang. Anyway, the JWST has uncovered significant insider secrets about the birth and advancement of the universe, leaving us astonished. Famous physicist Brian Cox has pronounced that these noteworthy revelations could possibly reshape our appreciation of the universe as a whole. Go along with us as we dive into these new heavenly disclosures that promise to change our comprehension. The JWST, named after recognized NASA overseer James E. Webb, addresses a wonder in present-day cosmic investigation. It is a critical, innovative jump forward from its ancestor, the Hubble Space Telescope, coming about because of a cooperative exertion between NASA, the European Space Agency, and the Canadian Space Agency. The JWST surpasses the capacities of its trailblazer, utilizing cutting-edge innovation and a plan streamlined for concentrating on the universe in extraordinary detail. Not at all like the Hubble, the JWST conveys clear and sharp pictures of far-off heavenly bodies by working basically in the infrared range. This exceptional element permits it to enter inestimable residue and catch heavenly objects that were recently stowed away from view. With its titanic 6.5 m essential reflect made out of 18 hexagonal fragments, the JWST dwarfs the Hubble's reflect in size. Situated around 1.5 million kilometers away from Earth at the second Lagrange point, L2, it circles the Sun in sync with Earth, guaranteeing a stable and continuous perspective on the universe while peering into the far-off corners of the universe. Includes exploring light years. It likewise involves a type of time travel. The JWST uses infrared instruments to notice divine articles and occasions going back billions of years. Due to the extending universe, the light radiated by these items goes through redshift, moving from the noticeable range to the infrared frequency or longer. Luckily, the JWST can distinguish this infrared light, empowering researchers to concentrate on the introduction of stars, investigate system arrangement, and explore exoplanet environments. One of its latest pivotal revelations involves identifying an incomprehensible mass of systems at the edge of the discernible universe. This finding challenges the legitimacy of the theory of the universe's origin, provoking a reassessment of our crucial cosmological suspicions. To better comprehend how we arrived at this point, we should momentarily audit the set of experiences of space investigation. Early civilizations, for example the Greeks and Chinese, laid the foundation for understanding planetary movement by noticing heavenly bodies. Newton's regulations in the 17th century provided a hypothetical structure to space travel. In the mid-20th century, Edwin Hubble, a compelling cosmologist, made notable disclosures in cosmology and observational stargazing. His perceptions uncovered that far-off nebulae were isolated universes, a long way past the Milky Way, changing our comprehension of the universe's size and scope. Hubble's regulation, laid out by him, showed that worlds farther away were moving away at higher rates, giving proof to the development of the universe. The post-World War II period denoted the start of the space race with the Soviet Union's send-off of Sputnik in 1957 as the first fake satellite in orbit. Yuri Gagarin's orbital trip in 1961 and the Apollo 11 moon landing in 1969 were crucial accomplishments. Fast forward to 1990, the Hubble Space Telescope was sent off, giving exceptional clarity and amazing experiences into the universe. The excursion from old perceptions to the innovative wonders of the JWST grandstands the ceaseless advancement of how we might interpret the universe. The Hubble Space Telescope revealed the endlessness of space and changed fundamental thoughts in astronomy. For example, it caught the famous Hubble Deep Field image in the Great Cloud, uncovering a star nursery shaped by immense sections of gas and residue. Another important accomplishment was the Hubble Deep Field, which caught huge numbers of systems in seemingly a void patch of space. The Hubble additionally dug into exoplanet atmospheres, pinpointing components like water and organic particles in far-off universes, alluding to the chance of livable zones beyond our planetary group. Following the advancement of the closest observed supernova, SN 1987A shed light on the life cycle of gigantic stars. These achievements solidified the Hubble Space Telescope's legacy as a foundation of present-day space science, enamoring the world with its shocking vast revelations. Its replacement, the JWST, was sent off to build on the mechanical advancement and illustrations gained from the Hubble. An example is how we might interpret the universe's beginning, which today is made sense of by the predominant Big Bang hypothesis. Around 13.8 billion years ago, the universe started as a seriously hot and thick peculiarity, quickly expanding and bringing about matter, energy, and central astronomical forces. As the universe extended, it cooled, prompting the arrangement of particles, stars, worlds, and the different structures noticed today. The Big Bang hypothesis likewise represents astronomical microwave background radiation, light element overflow, and the huge-scale design of the universe. In spite of the fact that broadly acknowledged, now the theory of how things came to be faced incredulity and difficulties almost immediately. Elective models, like the steady-state hypothesis, proposed a universe without a solitary starting. Concerns about proof supporting the initial peculiarity, the development system, and noticed peculiarities emerged at this point. Most protests were tended to over time. A vital piece of proof accompanied the recognition of inestimable microwave background radiation in 1965, lining up with Big Bang expectations. Space missions like COBE and WMAP, alongside adaptive advancements, further upheld the hypothesis. Exact estimations of cosmic microwave background radiation adjusted amazingly well with hypothetical expectations. Enter the JWST, furnished with cutting-edge infrared instruments that can look through cosmic dust mists and work essentially in the infrared range. The JWST catches the slightest, most established light in the universe and notices objects framed presently after the Big Bang. Its infrared abilities permit it to concentrate on star-forming areas, heavenly nurseries, and the introduction of stars, darkened from optical telescopes. Infrared light's longer frequencies, contrasted with apparent light, enter interstellar dust mists, defeating a limitation of the Hubble Space Telescope. The JWST can notice cooler items discharging basically in infrared, making it ideal for contemplating peculiarities like exoplanets, earthy-colored diminutive people, and far-off systems. As heavenly bodies move away, their discharged light waves get extended, causing a shift toward longer wavelengths, or redshift. The JWST's infrared abilities identify these redshifted signals, catching light from the early universe and offering bits of knowledge into its arrangement and development. Fiery occasions, like black hole formations or new star births, produce overwhelmingly in the infrared range, further expanding the JWST's investigation capacities. The telescope can investigate peculiarities that are generally covered up or undetectable. It supplements optical telescopes like the Hubble by having upgraded responsiveness and the capacity to identify infrared radiation, permitting it to peer farther into space and dig deeper into inestimable history. The JWST fills in as our window into the earliest phases of enormous improvement. As of late, it uncovered something so astounding that it might prompt a re-examination of the whole cosmological model of the universe. We've found immense masses of cosmic systems at the actual edge of the detectable universe, existing only a few 100 million years after the Big Bang. That's what vast first light. The confounding part is we're questionable about how such enormous structures framed so right on time in the universe's set of experiences. This revelation may lead us to rethink our comprehension of the arrangement and advancement of worlds in the early universe. Contemplating early worlds is vital for unwinding the mysteries of inestimable beginnings. Science can acquire insights into how universes, stars, and planetary frameworks arose and developed over billions of years. These perceptions likewise add to more extensive inquiries concerning the central nature of the universe, including its piece structure and the powers overseeing its advancement. While the Hubble Space Telescope was weighty for its time, it had restrictions in noticing the early universe. Its primary limitation was its failure to really infiltrate astronomical residue and recognize the infrared light radiated by old cosmic systems. More seasoned telescopes depended on apparent and bright light perceptions, making it challenging to investigate the early universe, where these frequencies are absorbed or twisted by inestimable residue and gas. The JWST addresses an extraordinary leap forward in noticing worlds from the universe's outset. Not at all like its ancestors, the JWST can notice heavenly articles that framed inside a couple of 100 million years after the Big Bang. Utilizing its infrared awareness and advanced imaging capacities, it has uncovered an abundance of antiquated systems, offering extraordinary lucidity and detail in figuring out the universe's developmental sagas. The primer results from JWST perceptions have mixed swells in laid-out cosmological models. Detailed information challenges a few parts of winning speculations, provoking cosmologists to reconsider basic standards administering our comprehension of inestimable advancement and construction. Inconsistencies between noticed information and hypothetical expectations have ignited extraordinary discussions inside the logical local area. The JWST perceptions revealed a higher number of worlds in the early universe than anticipated by existing models, proposing a more mind-boggling and quick development process. Some noticed early cosmic systems show up more advanced than expected, challenging customary models foreseeing more slow improvement. The discovery of an unfathomable mass of systems challenges the assumed conveyance and course of action of enormous structures, uncovering a fascinating and complex introduction of the universe. All in all, the JWST is reshaping our comprehension of cosmic beginnings and improvement by uncovering new understandings. As it proceeds with its groundbreaking mission, it guarantees to illuminate the universe's concealed tales and give hints to the interconnectedness of existence. Its insights will push the limits of current astronomy and help us answer essential inquiries regarding our position in the universe, keeping alive the human quest for knowledge.